Hello and good morning, good afternoon, good evening from Karlsruhe in Germany. My name is Adrian Fiege and I'm part of the EDXRF product management team of Bruker. It is my pleasure to welcome you to our webinar event about the new HighSense XP detector for the S2 PUMA Series 2, our powerful energy-dispersive X-ray fluorescence spectrometer. Today we will cover the following topics. First of all, we'll talk about what's new with the new detector, its specs and so on. Then we'll cover the benefits illustrated by several application examples. Then we'll talk about what's important with the software. And then I will cover what else matters when choosing the optimal XRF solution for your applications. I'll provide a short summary, and then we'll have a Q&A session during which you can ask your questions. So let's get started. The HighSense XP is based on state-of-the-art detector technology, and it is powered by our next generation of our versatile and intuitive Spectrometer software, SPECTRA Elements. The XP sets a new benchmark in the field of EDXRF detectors and is the new high-end premium detector of our S2 PUMA. The HighSense XP is equipped with an ultra-robust yet high-transmission graphene window and makes use of Bruker's own chip technology. Like all the detectors of the HighSense class, the XP does not require liquid nitrogen and uses electric Peltier cooling. The cooling setup has even been enhanced for better performance. With the HighSense XP, we also added a new feature to our software, which we call dynamic detector profiling. Later during this presentation, I will tell you a bit more about what this means and how this feature can help you with your application. The excellent transmission of the 0.9 micrometer graphene window of the HighSense XP is illustrated here in this plot. For manganese, for magnesium and aluminum in gypsum. Compared to the HighSense LE, here shown in green color, the HighSense XP, shown in blue color, offers typically 30% higher transmission. As you can see also from the graph, the difference can even be more significant when comparing the HighSense XP to our HighSense standard detector with the beryllium window, shown in gray color. The HighSense XP does not require silicon grid, and this minimizes the diffraction peaks and results in a cleaner spectra, and also results, of course, in better performance, especially for silicon. In this table, we summarize the key specs of the HighSense detector family. Clearly, the XP is added on top and shows the best performance for all elements detectable with EDXRF. The HighSense XP is also the only detector of the HighSense family which comes with the new dynamic detector profiling feature. This feature allows you to boost the count rate up to 2.4 million counts per second or enhance the energy resolution below 132 eV at manganese K-alpha. The HighSense Detector series really unleashes the S2 PUMA Series 2. It makes use of the 50 watt power tube, and here the 10-position beam filter, the direct excitation, the closely coupled beam optics ensure an optimal excitation of your sample, and then the HighSense detectors can process the achieved high intensities fast and reliably, which pays back immediately in precision accuracy and allows for shorter measurement times. A direct benefit of the HighSense XP are the low limits of detections which can be achieved due to the ultra-high transmission graphene window in combination with the high count rates. This plot here illustrates the achievable lower limits of detections under optimal conditions, which means, for instance, using vacuum for light elements. Now let's dive a bit deeper and talk about some applications. First of all, I wanted to focus on geological materials. Nature is complex, and so are the geological processes that lead to the formation of numerous rock types and minerals on our planet. From a geochemical perspective, this means that we are dealing with an extreme variation in major and minor and trace element composition. The geochemical composition of individual rocks and mineral types leads to distinct characteristics which make them valuable resources for both scientific and commercial exploitation. This demands for a versatile analytical solution. For the S2 PUMA with HighSense XP detector, we offer GeoQuant Basic. This is a powerful analytical solution which was developed for the analysis of major and minor elements as oxides in geological materials. It comes with a set of 20 certified reference materials, or CRMs, which include limestone, feldspar, gypsum, refractories, dolomite, for instance. It also comes with 4 dedicated QC samples to check the quality of your calibration and your solution. And it covers 14 key elements in geological compounds. As you can see here, considering the wide range covered by GeoQuant, shown in a table here on the right-hand side, as well as the large number of elements that is covered by the solution and the type of samples, GeoQuant is ready for various applications. This can include mineral ores, industrial materials, refractories, ceramics, and glass, and more. It is particularly suitable for central and research labs, as well as environmental labs, which are dealing with various sample types, but also for raw material and process monitoring at production sites and mineral processing plants. Here, I selected gypsum as an example to highlight the accuracy of the GeoQuant Basic solution with the new detector. Particularly impressive is the accuracy for the 3 major elements, calcium, sulfur, and magnesium, here all over to the right side. Next, we performed a test comparing the lower limits of detection which can be achieved with the HighSense XP detector to the HighSense standard detector with beryllium window. As mentioned at the beginning, the XP offers clearly benefits for light elements, and this is actually results in a significant improvement for geological samples, as shown here for sodium, magnesium, and aluminum. Especially for sodium, the improvement of the lower limit of detection can be as high as 250%, while as for aluminum, we still have an improvement of about 15%. Next, let's talk about building materials like cement and related raw materials and intermediate products. Here we offer CementQuant, also for the new HighSense XP detector. It provides a workflow that allows you to meet good laboratory practices. It includes a set of check standards and check procedures for the instrument stability and repeatability checks for the sample preparation. It also contains a set of predefined applications for EDXRF analysis, for instance of process material, like clinker and cement. With cement comes a set of internationally certified reference materials which allow you to set up and create a calibration that is traceable to NIST standards. You simply have to follow 3 steps. You do the preparation as fused beads of the CRMs. You measure the beads with the CementQuant, and then you have your calibration ready to analyze and traceable to NIST. Here I show the results of a repetition test where a cement quality check sample was measured 20 times. The sample was loaded and unloaded automatically between the measurements using our XY auto changer. As you can see, we obtained an excellent standard deviation with the S2 PUMA and the new detector. This is particularly visible here from the standard deviations and the relative standard deviations. For most of the elements, the relative standard deviation is quite well below 1%. Now let's switch to a different solution, and that is SmartQuant FP. SmartQuant FP is our versatile standardless solution package for the S2 PUMA, which is also available with the new detector HighSense XP. It is based on full fundamental parameters and is fully integrated into our software package, SPECTRA Elements. It allows to provide elemental compositions for solids, fused beads, pressed pellets, powders, liquids, and even with minimal input. So this is really a versatile solution that provides excellent results and an excellent opportunity to test raw materials, but also whenever you have special out of the typical production samples outside of your routine measurements, and those need to be measured for analyzed for potential process adjusting processes. SmartQuant FP covers elements from fluorine to americium and from concentrations of ppm up to 100%. It supports the modes air, helium, and vacuum, and you can choose whether you want the system with our 50 kV settings or whether you just want the degrees setting with 30 kV for specific regulations in your region. Now let's take a look what SmartQuant FP with the new detector can do for you. Here I'm showing results for Vespaloy, so nickel alloy analysis performed with SmartQuant FP. Clearly, our standardless solution can achieve an outstanding accuracy, for instance, for nickel, chromium, and aluminum. Over here you have the nickel, for instance. And we have also another example, and this is the second example here. This is for high aluminum cement. Again, the results are quite impressive, even for the major elements, but also for the minor elements like the light element magnesium here. Now let's talk about our new feature, the dynamic detector profiling. Dynamic detector profiling is a new fully integrated feature in SPECTRA elements. This means when you set up a method, you can select for a given range, meaning for a given excitation voltage, if you want to boost the count rate, enhance the energy resolution, or use the default settings. For instance, when you're dealing with neighboring peaks of major components and trace components, you may want to choose the high resolution setting to enhance the peak separation. Or if you want to achieve lower limits of detection for heavier elements, you might want to boost the count rate to get lower limits of detection. As you can see here in this example for a cement measurement, with the high count rate, you can achieve up to 400% higher intensity for cement sample. And this really pays back and can be used, for instance, to reduce the counting time and therefore increase the throughput substantially. As mentioned, you can simply choose the different profiles during the method setup, and there's a drop-down menu shown here by this example from our SPECTRA, from SPECTRA elements, where you can select the different ranges. To show you the high potential of these features, we performed a precision test with a cement QC sample using different counting times and comparing the high count rate to the default detector profile. The total counting time was 190 seconds or 600 seconds, and we performed 25 repetition measurements. Again, the samples were loaded and unloaded automatically. Here I show the results for 3 examples. In gray, you see the result for 600 seconds with default settings. In blue, you see the results for 190 seconds with the default setting. And in orange, you see the results for 190 seconds with the high count rate. As you can see clearly, this highlights that you can improve the counting time, or basically decrease the counting time by a factor of about 3 without compromise on the precision of your measurement by choosing the high count rate setting for cement and related applications. Now we can go one step further and compare the results obtained with the HighSense XP and the high count rate for the 190 seconds with the limits of the cement norm ISO 29581 or the European norm, basically nowadays valid, the 196-2. Clearly, we can see that with these settings and the new HighSense XP and our high count rate, we are well below the limits of this norm, as well as the normal, as well as the expert limits. So this shows again the suitability of the PUMA with the new equipment for cement and related applications, such as limestone. Now let's talk about software. What are we expecting from a modern software? Well, yes, it should work and it shouldn't give us any headaches. It shouldn't freeze or something like that. But there's more to it. The modern software needs to be intuitive. It needs to have an intuitive interface, easy to learn, but it needs to keep the full functionality and options at depth to provide the best performance. You need, for instance, different user levels, like a lab manager mode and an operator mode. You want short processing times and a high stability at all times, so no connection failures or freezing. And you want a flexible data management system that allows you to get access to your data in the way you need it and in the way it makes your life easier. In summary, you can say that the software needs to be performing to provide high performance, expected high quality results. But basically, we can also summarize that the software needs to save time. It needs to save time in terms of training, operation, and evaluation, and especially during routine daily operation. Here, Spectra Elements really performs. It sets new standards in the world of XRF spectrometer platforms. It's faster, smarter, and easier to use. It is based on contemporary programming and enables rapid processing, so there's no more waiting for spinning hourglass. The navigation is smooth at all times, and you have rapid access into the results in all different ways in the database and a smooth operation. Spectra Elements comes with a variety of powerful features that make your life easy and result in excellent performance. Some examples include the dedicated user levels and views, like for instance an operator level and a lab manager level. It also includes the loss-eliminated alpha, which allow routine measurement of ignited samples without dedicated input of loss on ignition. It includes the pressure compensation for measurement of light elements in air mode. And it includes powerful post-processing options to make your life easy when it's about data management and further processing of your data. Of course, the S2 PUMA with its XY automation is fully ready for automated environment and can be integrated in your automated environment system. Spectra Elements is also very easy to use. You have a very easy learning curve, so basically the operator can start after short introduction to run the system, and it also provides hints in case you might be stuck in some position. The wizard, for example, has a proven tree structure and is used for the calibration, so it guides you through the process of the calibration easily. And the loader for a daily operation, routine operation, is really intuitive. So you can load the samples easily, choose the method you want to use, and then you can change priorities, change sequences, unload, stop the sample, and even view the results. In the Results Manager, you have access to all your data and can get extended or reduced reporting. Doesn't matter what you need, you can set it up. And you can, of course, also re-evaluate your data at any time. So after we've learned quite a bit about the performance of the S2 PUMA when equipped with the latest software and detector technology, I would like to spend a few more minutes to talk about other factors which are important when selecting the right XRF equipment. First, you should think about the sample handling. Here, the decision-making factors are mainly the number of samples per day, type of samples, and the sample sizes. To provide the perfect fit for your requirements, we offer the S2 PUMA in 5 different configurations and can really provide a tailor-made solution for you. We have, for instance, the single manual loader for a few samples per day. We have the XY auto changer for highest throughput and flexibility. On top of the XY auto changer, we can add an automation interface for fully integration into automated environments. And then we offer the color cell in case you're dealing with various types of sample sizes, and the color cell actually comes with the largest EDXRF chamber on the market. And then we have also the mapping stage, a dedicated solution for multi-position spot analysis, quality control analysis, especially for the semiconductor industry. But there's even more to consider. In particular, you need to think about the elements of interest, of course, the concentration ranges, and the sample preparation. And this, of course, defines other factors like the optimal atmospheric mode. The PUMA comes with all relevant atmosphere modes, so vacuum, helium, air, nitrogen. Typically, you would choose vacuum when you're looking for lighter elements because it also results in low cost of operation. Of course, the PUMA can handle all sample times, from liquid to solid, from pressed pellets to powders, and so on. We all know that there's quite some truth in the statement, time is money. And this means you need an instrument that is reliable and fast, but also easy to operate after short introduction. All of this applies to the S2 PUMA Series 2 with SPECTRA elements. SPECTRA elements was really designed with the user in mind and combines ease of use with functionality. The touch control interface allows the operation of the device with the push of a button and without external PC. Our unique sample care technology, the smart maintenance features within SPECTRA elements, as well as the option for getting remote support, result in high uptime and easy and fast maintenance. Now, before we switch into the Q&A session, I would like to give you a very brief summary. So we've learned today that the HighSense XP is the new premium EDXRF detector, and it really pushes the S2 PUMA Series 2 to its next level. The detector profiling feature allows to improve the analytical performance even more by reducing, for instance, the counting time or allowing a decrease of a lower limit of detection. SPECTRA Elements is the next generation of spectrometer softwares, and it's now even faster and comes with additional features to make your life easy. And we've also talked about our out-of-the-box solutions, which make you ready to perform from day one. So with that, I want to switch over to our Q&A session. Okay, Frank Portala will support me during this Q&A session. So Frank, would you please go ahead and see if there are some questions and ask me those questions if possible.
There are a few questions so far. You can still post questions if you want, but let's start me with the first one here. Adrian, Aman asked, can you explain how the detector profiling works? It wasn't entirely clear to me.
Okay, thank you for that question. I will do my very best to try to explain how the detector profiling works. So basically, in a very short summary, detector profiling works based on the peak shaping time. So the peak shaping time is important. The longer you allow your peaks to shape up, the better your energy resolution gets. There's typically for each detector a sweet spot, and for modern detectors like the HighSense XP, you have the sweet spot at very low energy resolution and short, and still being able to have short peaking times, so therefore allowing high count rates. And here with the new detector, we are able to just change the peak shaping time slightly, which has some effect, but not very huge, on the energy resolution, but at the same time allows us to get much higher count rates. Vice versa, we can increase the energy resolution a little bit, but while not compromising too much on the counting time. So this is basically how it works.
Here is another one. Roger from Spain wants to know, when is the new detector available?
Okay, the new detector, the HighSense XP, is basically available now, to cut a long story short. So if you have currently a project, reach out to your representative, your broker or distributor representative, ask him about or her about the new detector, and he will explain you or she will explain you if this detector is something for you, and then can also provide a quotation.
Another question comes from Rachel. Is there any benefit for forward and feed analysis?
In the feed and forage and animal nutrition business, there are multiple elements of interest. This can include, for instance, phosphorus, but also magnesium, depending on if you're talking about premixes or final forage and feed products. You might also be interested in heavier elements. The HighSense XP provides, generally speaking, the best performance for all the elements of interest for food and feed and forage applications. However, it depends on your specific requirements whether you need to go to the HighSense XP or whether you can, for instance, use the HighSense standard detector. Particularly, there's a cutoff at the lighter elements. So, for instance, if magnesium is of interest, then the HighSense XP is typically the optimal choice, depending on its concentrations. And then again, you benefit with the HighSense XP, of course, with the higher count rates, especially since with feed and forage application you have light matrices. So there you can enhance your throughput or maybe improve your lower limits of detection. So the answer is yes, but this doesn't necessarily mean that for all your applications you need the HighSense XP.
Here is a question from Pete from the US. Pete wants to know if the systems get pre-calibrated for additives and lubricants.
Okay, thank you, Pete, for this question. We have a couple norms which we are compliant with the S2 PUMA, and then I also want to highlight that we have the S2 Polar, our dedicated analyzer for petrochemical materials, so you want to check that out as well. When you decide to purchase a certain standard set with the system for a certain petrochemical norm, maybe additives and lubricants, then, and this is listed so you can check out our website, for instance, then we can also calibrate the system so that it's ready to go once it arrives at your site.
Okay, Adrian, looks like that we are reaching the end. Oh, here's one more. Tom is asking about GeoQuant. Can he use it for limestone?
GeoQuant, yes. So yeah, of course you can use it for limestone. We spent quite some time today on our solutions, so CementQuant and GeoQuant. So maybe I should emphasize there that one usage or one key usage of GeoQuant Basic is actually to use it for raw materials such as limestone in the cement production. So you might even combine CementQuant with GeoQuant Basic on a PUMA, and you use the GeoQuant Basic for your incoming raw materials. And the CementQuant you use for your intermediate and final products, and also to be compliant with the norm ASTM C114. So the answer is yes. The quant packages like GeoQuant are also excellent solutions to get started and to allow you to perhaps build secondary calibrations based on your dedicated samples, so build secondary reference materials, and then be able to calibrate the system accordingly within the smaller thresholds or the smaller range of materials that are actually used on your side. Yeah. Okay, I guess now we are done with the questions. So I would like to thank you very much for your time, for your interest in this webinar, in this launch of the HighSense XP detector and in our products in general. I hope you learned something, and that you, if you are interested to learn more, you can reach out to me or to us in general. And I hope to see you sometime in the future in person. And I wish you all a great day. Thank you very much.